Okay, so this is a good example for us to work through. Um, what I'd like to do is kind of follow the approach that I had been kind of recommending to you of, let's think about this in terms of, you know, um, the three different ways of approaching any kind of problem, in terms of words, in terms of pictures, in terms of equations. Um, here we're kind of being given sort of some words and sort of some equations. So maybe one way, if you're feeling lost on a question like this is, well, okay, maybe I'll try the other way that hasn't yet been immediately, pushed in my face here. Let's try to think about this in terms of a picture. So what kind of a picture might we go to that could be relevant to this? Any? Yeah, absolutely. So an information graph is definitely a way of looking at these same things, like these equations, now as a picture. So let's do that here. So actually, we already sort of did it. So let's think about these two pictures. So what we're interested in is getting the likelihood of these two variables under the mismatch model versus the match model under the assumption that these were basically like 0.5 and that we can pretty much forget about the kappa values that are any value other than 1, right? That was what you were being told in the problem. So one way of approaching this picture problem would just be to look at the edges and say, which of these edges are going to be the same in these two models under the circumstances that we've just been told? Well, kappa equals 1, probability of x equal 0.5 given kappa equals 1. So we've got that here. We've also got it here. So I can kind of check off those two edges and say, those two models, they both share that same edge. So that's not something that's going to be a difference between these two models, right? And similarly for S, I've got probability of S given genetic state equals 1. So I've got that here, and I've got it here. Same thing. So I'll just put another check mark to indicate that I've got those edges basically identical in the two models. So I'm starting to run out of things that could be different, right? I don't have very much left. In fact, over here, I only have one edge left. So that's it. The thing that can be different between these two models is basically I have to get probability of kappa equals 1 given theta once here, but twice here. What that's basically saying is, yes, it's possible for us to get x and s both being 0.5 under the mismatch model. That's possible, right? I mean, it can just, by random chance, you get two individuals who happen to have that polymorphism. I mean, that's possible. That can happen with a certain probability. What is that probability? Well, it's that probability. It's the probability determined by basically multiplying that likelihood times that likelihood. Whenever you see it in one of these branchings, it means we're treating these are conditionally independent given that. It means we multiply those two likelihoods, right? So that number is the same as that number and that number, except we have to multiply it twice over here and only once over there. Okay, so if theta were, some small value like 0.1, then this is 0.01, like 1%, so say a rare polymorphism, then this is it's basically going to be like multiplying by an additional factor of order of magnitude 0.01. We can make this model be, order of magnitude something like 100 times less likely than this. Why? Because here we have to pay for that likelihood twice. And here we only pay for it once. Okay? So do you see, hopefully, the benefit of thinking about this problem pictorially? I mean, you could write out the equations and you'll get exactly the same thing. And that is a good exercise, for you to look at on your own if you wish. But the point here is that, if you're feeling lost with the words in the equations, something that might be quite helpful would be to go look at it as a picture. And oftentimes by going back and forth between the picture versus the equation versus the words, you'll keep finding something that takes you to the next step. You don't get just completely stuck. And the value of the picture, of course, is that it lets you see the whole problem at a glance without getting lost in the details. I mean, each one of these edges has got like a big honking likelihood expression in it, there's a big normal distribution there, or what have you. But by looking at this, I can say, well, that's going to be the same as that, and that's going to be the same as that. So forget about those, and it doesn't affect anything. Okay, what's left? Okay, so I see some differences. Questions about this? In the equation, yes, what's going to happen is you're going to have terms that you could cancel in the odds ratio between the two models. You'll be able to cancel those terms. Other questions? Things that this makes you wonder about? Does this seem useful? Way of thinking about it?